Good morning, friends. This is Cauchy's Inequality Theorem, and it states that suppose function fz is analytic inside and on the circle C, having the center at z0 and radius r, right? So if mod of fz is less than equal to m on the circle C, then we have to show that nth derivative at z equal to z0, its mod is less than equal to m into n factorial divided by r the power n, where this r is the radius of the circle and this z0 is the center of the circle, right? Because on the left hand side, I'm having nth derivative of fz at z0. So for the proof, I can make use of the Cauchy's integral formula for the higher derivatives, right? So let's start with the proof. This is the circle, z minus z0 equal to r, centered at z0, having the radius r, right? And your function is analytic inside and on the circle C. So by Cauchy's integral formula, we know that nth derivative of the function at z0 is equal to n factorial divided by 2 pi iota integral over C f of z divided by z minus z0 the power n plus 1 dz, right? Because in the result, I'm having the mod, so let's take mod on both the sides. And then it is less than equal to n factorial divided by 2 pi. Mod of iota is 1. And integral over C, mod of fz divided by mod of z minus z0 the power n plus 1 mod of dz. And because it is also given to us that mod of fz is less than equal to m on C and z minus z0 is equal to r. So I'm using this in the next step. So this is further less than equal to n factorial divided by 2 pi integral over C, and mod of fz is less than equal to m. That is why less than equal to sign is over here. So this is m divided by z minus z0 is r. So this is r the power n plus 1 mod of dz. Let's take all these constants outside of the integral. So this is equal to n factorial divided by 2 pi m divided by r the power n plus 1 integral over C mod of dz. And because this integral is on the circle, and for the circle mod of dz, the integration is, yes, it is simply the circumference, that is 2 pi r. So this is n factorial divided by 2 pi m divided by r the power n plus 1 into 2 pi r. So this 2 pi will go, and the power of r becomes in the denominator as r the power n. So this is m into n factorial divided by r the power n. And the sign is not equality, but the sign is from here, that is less than equal to, for this left hand side. So hence, mod of nth derivative of the function at z equal to z0 is less than equal to m into n factorial divided by r the power n, hence proved. Okay, thank you.